Welcome back to the Bluewater Auto Restoration Podcast, everybody. Week 21 of 2025, and we're diving into a topic that's really got our gears turning here at the shop.
Oh, yeah.
3D printing. Now, we're not just talking about those little plastic trinkets you might have seen.
Right.
We're going deep into how this technology actually works, the different types of printers out there, and what you can really do with it, especially when it comes to restoring those classic beauties.
You know what's fascinating about 3D printing is that it's been around longer than most people think.
Really?
It's not some futuristic tech. We're talking about a process that's been evolving since the 1980s.
Wow. I remember seeing those early prototypes, pretty mind-blowing back then, but now it seems like 3D printing is everywhere, from hobbyists, workshops, to, right here in our auto restoration shop.
Mm-hmm.
So let's break it down. What is 3D printing at its core?
So think of it like this. Instead of starting with a block of material and carving away at it, like traditional sculpting, 3D printing builds things up. Layer by layer, it's an additive process using a digital blueprint to guide the creation of a physical object.
Okay, so like building a brick wall.
Uh-huh.
But instead of bricks, it's using plastic metal or even rubber.
Exactly. And just like with a brick wall, the strength comes from how those layers are laid down.
Interesting.
Early on, 3D printing was mostly used for prototyping, creating models of things like TV remotes or car parts. It was expensive back then, but still cheaper than traditional methods.
Oh, I bet. But then something pretty incredible happened in 1984. Stereolithography, or SLA, was invented. And guess what? We still use SLA today.
Yeah.
Even in high-tech fields like dentistry.
It was a game changer. SLA uses a liquid resin that's hardened layer by layer using UV light. It's known for producing incredibly detailed prints, almost like miniature squares.
That's awesome. So we've got this additive process, we've got SLA, but there's got to be more to the 3D printing story, right?
Absolutely. The real turning point was around 2005 with the BWAR project.
Okay.
They created a 3D printer that could actually print most of its own parts.
We had a printer that can print itself. That's straight out of science fiction.
Right. It was revolutionary. The BWAR project made the technology open source, meaning anyone could access and modify the designs. This led to an explosion of innovation with people building and refining 3D printers at home.
Wow.
Driving down costs and making them accessible to a wider audience.
That's amazing. So we've gone from expensive prototyping to DIY printers. That's a pretty incredible leap in a relatively short time.
It really is, and it's important to understand that 3D printing isn't just one monolithic thing. There are actually several different technologies used to create those layered objects.
Okay, so like different types of printers for different jobs.
Exactly. Let's start with the most common one, FDM, or fused deposition modeling. Sometimes it's also called FFF, or fused filament fabrication.
Right.
Basically, it works by melting a plastic filament and extruding it through a nozzle, like a tiny hot glue gun, building up the object layer by layer.
So that's what those spools of plastic filament are for. But even within FDM printing, there are different types, right?
Yeah. You got it. The way the printer's axes move can affect the quality and speed of the print. There's Cartesian, which is your typical X, Y, and Z movement. Think of the print head moving left and right, forward and back, up and down. Then there's Delta with 3 arms that move really fast, and Core XY, which uses belts and pulleys for smoother, more precise movements, especially over larger areas.
So if you're printing something big and detailed, like say a car part, you might want to consider a Core XY printer.
That's a great point, and choosing the right type of printer is something we'll definitely delve into deeper. Now remember SLA, the one that uses resin?
Yeah.
Well, that's another popular technology, and it's known for incredibly fine details and smooth finishes.
Okay.
It's perfect for things like miniatures, jewelry, and even dental applications.
Wow. So 2 totally different technologies for very different results. But there's one more you mentioned, right? SLS or DMLS?
Yes, those are more industrial processes. SLS uses a powdered material that's melted and fused together by a laser layer by layer.
Mm-hmm.
It's great for creating very precise and durable parts, but it's also quite expensive.
So lots of options to choose from depending on what you want to achieve. I'm already starting to see how 3D printing could be a game changer for restoring classic cars. But before we get ahead of ourselves, let's talk about actually choosing a printer. What factors should someone consider before taking the plunge?
Welcome back to the Bluewater Auto Restoration Podcast.
It's time for part 2 of our deep dive into 3D printing. And last week we left off talking about choosing the right printer. There are so many options out there.
Right.
It can be a little overwhelming. What are some of the key things people should be thinking about?
The first thing I always tell people is don't just focus on the price tag. It's easy to get caught up in finding the cheapest option, but the most important thing is to consider what you'll actually be using the printer for.
Right. I mean, if someone is just printing little figurines versus someone who wants to print functional car parts,
Yeah.
they're going to have very different needs.
Exactly. If you're planning on printing larger objects, like those car parts you mentioned, you'll need a printer with a larger build volume, but bigger isn't always better. Larger prints can be prone to warping, which is when the plastic cools unevenly and the object bends out of shape.
Oh, yeah. I can see how that would be a problem, especially if you're trying to print something precise.
Right.
So bigger build volume for bigger objects, but keep warping in mind. What else should we be thinking about?
Another important factor is the printing material. We talked about different types of filaments and resins, and each has its own strengths and weaknesses. Some materials are easier to print with, while others require more specialized equipment or settings.
So if someone's just starting out, they might want to stick with a printer that uses a more beginner-friendly material like PLA. But if they want to print something really durable, they might need to look into a printer that can handle something like nylon or ABS.
You got it. And don't forget about the community aspect. The 3D printing world is full of passionate makers and tinkerers, and there's a huge online community where you can find support, troubleshooting tips, and even downloadable designs.
Yeah, that's something I really love about this technology, the open source nature of it. People are constantly sharing their knowledge and designs, which really helps everyone learn and grow.
It's a fantastic resource, and it's a great way to get inspiration for your own projects now. Once you've chosen a printer, the next step is finding or creating the 3D model you want to print. There are tons of websites where you can download pre-made designs, everything from toys to tools to, you guessed it, car parts.
Oh, cool. So even if you're not a 3D modeling whiz, you can still get started with printing some pretty awesome stuff.
Exactly.
But what if you want to design your own parts? Is that super complicated?
It can seem daunting at first, but there are some fantastic 3D modeling software options out there, ranging from beginner-friendly to professional-grade.
Okay, give us some examples. What are some popular choices?
For beginners, Tinkercad is a great place to start. It's free web-based and uses a simple drag-and-drop interface to combine basic shapes and create models. It's like digital Legos.
I love that analogy. So you're not starting from scratch. You're building with pre-made blocks. That sounds pretty approachable. What about something a little more advanced?
If you're looking to create more complex or precise models, Fusion 360 is a popular choice. It's a professional-grade software used by engineers and designers, but it also has a free version for hobbyists and students. It allows you to create intricate designs and even do some pretty cool sculpting.
And for those who are really into the artistic side of things, there's always Blender.
Absolutely. Blender is a free and open source software that's incredibly powerful and versatile. It's used for everything from 3D modeling and animation to visual effects and video game design. It's a bit more complex to learn, but the possibilities are endless.
So we've got our printer, we've got our 3D model. What happens next?
That's where the magic of slicing comes in.
Slicing sounds a bit ominous.
Yeah. Not at all. Think of it like taking your 3D model and slicing it into super thin digital cross sections like those potato chips we talked about earlier. These slices are then translated into instructions that your printer can understand, telling it where to move the nozzle, how much material to extrude, and so on.
So it's like turning a 3D object into a series of 2D blueprints that the printer can follow.
Precisely. And there are different software programs called slicers that help you do this.
Okay, what are some popular slicer options?
One that we use a lot here at Bluewater is Prusa Slicer. It's free, open source, and has a ton of features and customization options.
I've heard good things about Cura too. It's known for being very user-friendly, which is great for beginners. So once you've sliced your model, you're finally ready to hit that print button.
Almost we need to talk about materials. Remember, it's not just about choosing a color. Different materials have different properties that affect how they print and what you can do with them.
Right, we talked about PLA being easy to print, but maybe not the most durable, and things like nylon and ABS being tougher, but maybe a bit trickier to work with. So how do you choose the right material for the job?
That's a great question. It depends on what you're printing and what properties are important to you. Let's say you're printing a prototype for a new car part. You might choose PLA because it's easy to print and you can iterate quickly. But if you're printing a functional part that needs to withstand heat or stress, you'd probably choose something like ABS or nylon.
Okay, so choosing the right material is crucial. But what about all those different colors and finishes I see? Is that just about aesthetics?
Well, aesthetics are important too, but some materials come with added functionality. For example, There are flexible filaments like TPU that allow you to print rubber-like objects.
Oh, I bet that would be super useful for printing things like gaskets or seals.
Exactly. And there are composite materials that have wood or metal particles mixed in, giving you unique textures and properties. You can even find filaments that are conductive or glow in the dark.
Wow, the possibilities are truly endless. So you've chosen your printer, your material, you've sliced your model, you hit print, and then what is that it?
Not quite. There's one more important step, post-processing.
Okay, so this is where we take our raw print and make it look all fancy.
Exactly. Post-processing involves things like removing support structures, sanding down rough edges, filling in gaps, and painting or finishing the surface.
I imagine this is where those artistic skills come in handy.
Absolutely. And the level of post-processing you do really depends on the desired outcome. If you're printing a functional part, you might just need to remove supports and do a bit of sanding. But if you're creating a showpiece, you might spend hours meticulously smoothing and painting it.
So it's all about taking that raw print and turning it into something truly special, and that's what we do here at Bluewater Auto Restoration.
You got it. Whether we're printing a custom part for a classic car or creating a prototype for a new design, 3D printing has become an invaluable tool in our restoration process.
And speaking of restoration, next week we'll be diving into how 3D printing is specifically impacting the automotive world and what the future holds for this game-changing technology. So make sure to tune in for part 3 of our deep dive. Welcome back to the Bluewater Auto Restoration Podcast for the final part of our deep dive into 3D printing.
It's been quite a journey exploring this incredible technology. We've covered the basics, different types of printers and materials, and even delved into the design and post-processing aspects.
And today we're going to put it all together and see how 3D printing is shaping the future of various industries with a special focus on how it's revolutionizing the world of auto restoration.
It's amazing to think that what started as a niche technology for prototyping has now become an integral part of so many fields, and the automotive industry is definitely at the forefront of this 3D printing revolution.
You know, when I first heard about 3D printing, I thought it was all about making little plastic toys and gadgets. But the fact that we can now print functional car parts, even entire car bodies in some cases, is just mind-blowing.
It really is a paradigm shift.